Okay, we're back. This is week 7, and this week did a little bit of. Most of this week was spent on the side project I'm working on. So basically, me and my friend, we got the API to work. Currently still just doing some exploratory data analysis and really just begging the question on what questions we want to ask, essentially to uh, what exactly we want to do with the data set that we got. So that's going. Additionally, I started doing a machine learning crash course on Google. A lot of the stuff I already have exposure to just from like the previous things that I've done, but some of the stuff they talk about are pretty good. Uh, Most of it is coded in TensorFlow or using the library TensorFlow, so it's kind of difficult for maybe beginners to understand what's going on. Uh, but basically, but a lot of the theory and the conceptual topics they cover are really cool. So I'm just going to go over a couple of those really quickly. For example, regularization, simplicity, and specifically L2 regularization, which is basically you're punishing how complex a model is, right? So the problem with complex models is that you run into the problem is essentially overfitting. Basically, the idea is, let's say you have a training set and you train super well on the training set, like the training set is super complex, it's super accurate, but as soon as you introduce new data points into it, it doesn't really um it doesn't really fit the data well. So to give a quick example, I guess, is kind of like where, let's say, maybe I have a data point here, 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 and data point here. So maybe I can train my data to be something like this, right? I can do this, this, this. Whoops. So my machine learning model would fit like this curve, and it's like, hey, this is my predicted curve. So this is what happens when you run a super complex algorithm and yeah, that's what happens when you run a super complex algorithm. Now let's say I introduce a new point right here. Well, that's a problem, right? Because now this point is nowhere close to this line. You're going to have extremely high mean squared error or just error in general. So that's the problem. That's why regularization essentially introduces this new lambda, which I will actually show right here. Um, so this is the formula where it says minimize, you want to minimize minimum of the loss of the data model, which is, that I believe I talked about um, the loss function with linear regressions. And the complexity of the model, L2 regularization is we're using the weighted the squares of the squares of the weights. And the higher this value, complex models generally have really high weights. And when you have really high weights, that'll actually make this a lot higher, and you want to minimize this, right? So, therefore, very complex models are often rejected. That's why simplicity is usually really, really good. Um, and then lambda, it's just kind of this, uh, it's this multiplicity factor that you multiply by the complexity of the model, and when you put this all together, you want to minimize that. Um, and then distribution depending on the weight frequency or the weight value. So like right here, you could see that if you have lower lambda values, it makes it really flat, and then if you don't, it makes it looks very similar to the normal distribution or Gaussian distribution. So that's one thing. And another thing that they talked about that was pretty interesting is feature crosses, right? So like let's say um let's see here. Yeah, so let's say, you have this data set that you want to essentially you want to separate. You can't separate it with one specific line, right? But if you use something called a feature cross, which is x1 times x2, you can see that since this is 0 and this is also 0, you can think of it as everything in this quadrant and this quadrant are always positive values when you multiply the respective x1 and x2, right? Because quadrant 1 and quadrant 3 is negative negative, quadrant 1 is positive positive, right? And quadrant 2 and 4 respectively are negative, positive, and positive, negative, right? And these will actually generate negative values. So when you give this the corresponding when you give this the weight of 1, you can see that it actually separates this fairly well. And one thing that I want to emphasize is with the regularization, with the complexity of your model, is that when you use the problem when you introduce all these different functions and then you try to run this, you'll see that the model starts bending in very weird ways, and you can see how this is classifying, this portion as the yellow portion, but there's really not enough data to support that, right? So it starts making these really, really weird curves. So in this case, because you see how the model is, it's like, okay, it's this and split up into this, then you want to actually remove these feature crosses and generate this nice simple curve that minimizes your test loss and training loss. So for example, if I run this again with this, you'll see that the test loss and the training loss is actually higher the more epochs I give it. So I highly encourage, if you have a decent background with machine learning, like you've done maybe one or two projects on maybe Kaggle and understand a lot of the basics, then I had highly encourage you guys try this out because I did definitely think the concepts are worth a read, and some of these exercises are pretty cool. Yeah, but I'm gonna get through this for next week. Get through this. Try to really definitively define and find out what it is that we want to answer, what question we want to answer on the project, right? Um, and then try to get that done, and then obviously do a little more SQL, be more familiar with the language, try to do it like once every couple days or maybe once every other day or even every day if I find the motivation to do that. But that's pretty much it for this. Hopefully you guys learned something because I definitely learned a lot from this. Yeah, so I'll see you guys next week.